For this podcast, please have note page number 18 in front of you. The fifth in our series of organic functional groups is going to be the ketone. Here's an illustration of what the ketone is actually going to look like. As you can see, you have a double bonded oxygen within, that's the key, two different parts of an organic compound. All right, here is our double bonded oxygen found within the interior of an organic compound in order to make it a ketone. Now on page 18, a little bit more information on our ketones. Now what you have is you have a carbonyl group. There's our dash C with the double bond of oxygen located, here's the key, within the interior carbon, within an interior carbon within this chain. To name it, the E at the end of the alkanes is going to be replaced with an O-N-E, own. Must cite the location of the carbonyl group for this. It's often used in many solvents like acetone. Acetone is a product that's used in nail polish remover. Now be very careful. Like I said with the aldehydes, they're very similar to ketones, just like ketones are very similar to aldehydes. So be cautious. The main difference between ketones and aldehydes is with the ketone, you're going to find the carbonyl group within the actual interior portion of the chain, and with the aldehydes, it was found at the end in a terminal position. Okay, here we go. First example, we have two. You can see that the ketone has been named pentanone. All right, we're dealing with pent. So we know we have a 5-carbon chain. Here are our 5 carbons. All right, we know that at position 2, so if we're going to number from left to right, 3, 4, 5, we know in the smallest number possible, we're going to find the location of our carbonyl group. There it is. And we also know that everything else is going to be filled in with a hydrogen atom to complete the octet. So this is perfect right here. There's 4 bonds already. We have a bond here of hydrogen, 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 and then finally the last hydrogen. So we have 2 pentanone. Now, going in the reverse fashion. Here we've got our actual structure, so we're going to go ahead and name this. So let's name or number our carbon atoms. 1, 2, 3. Doesn't matter which direction you go in. You're still going to have the carbon atom located in the second position. All right, to name this, we have 1, 2, 3 carbon atoms, so we know that we're dealing with prop. Right, it would be propane gas, but we're going to go with a propane. And then here's the location of our carbonyl group. And within a ketone, it's located on the interior portion of our carbon chain. So we finish up with the O-N-E. Now, some of you may put a number position of where the carbon atom is located, which is great practice, but please understand that it's not necessary because we know that our carbonyl has to be located on the interior, so we can't put it at position 1 or position 3. It must be at position 2. So there's only one location for the carbonyl group to be at, so it's really not necessary to label with a number 2 if you want. That's perfectly fine. Obviously, I can't mark you wrong for that. So there you go, ketones.